So good afternoon and welcome everybody, wherever you are in the world, to today's webinar hosted by Bound for Blue. My name is Roderick Craig. I'm a journalist with Blue Sea Maritime Communications in Oslo, and I'll be moderating today's proceedings. So our objective today is to provide valuable insights into retrofit wind-assisted propulsion projects and share knowledge with you from three key perspectives. Firstly, we'll hear from our special guest, Gavin Allwright, General Secretary of the International Windship Association, who will review EU and international maritime regulations. Then Fabian Kowatsch of Louis Dreyfus Company will provide the charterer's perspective on the decarbonisation journey, why they opted for wind propulsion technology, and the challenges and steps taken towards project fulfillment. Following Fabian, Santiago Suarez de la Fuente of Lloyd's Register will describe the class society perspective on evaluating feasibility of installing wind-assisted propulsion and offer guidance and tips to ship owners on using the technology to meet compliance standards. David Ferrer of Bound for Blue will follow up with the wind propulsion vendor's point of view, explaining the technology and presenting its practical step-by-step incorporation into your fleet and regulatory impacts. So we've got a lot of great content to inform and inspire you, so please stay tuned. But before we get going, just some practical information. After the session, you'll all receive a survey link for your feedback, as well as a QR code during the Q&A session that will take you to a landing page where you can download the presentations, and we'll also email you a recording of the session for your information afterwards. Following the speakers' contributions, we'll have a Q&A session, so please write your questions in the question field, and you'll see at the top right of the screen a little box with a question mark in it. Click on that icon, which will take you to the question field. And we'll take those on a first come, first served basis. And it's also really nice if you include your name, the company you work for, and which panelists you'd like to address your question to. And for any questions we don't have time to respond to, we'll answer these separately by email. So without further ado, let's kick off first with Gavin. Gavin has led the IWSA since it was established in 2014, and he works very hard to promote and facilitate the uptake of wind propulsion in shipping. He also sits on the IMO Maritime Technology Cooperation Centre's Stakeholder Advisory Committee and is a non-executive board member of the World Wind Energy Association. So Gavin, over to you.
Yep, thank you very much. And if you could do my share screen, that'd be great. Just allow me, there we go. Okay. So I hope everyone can see the slides here. I'll just put that in presentation mode. There we go. So thank you very much for inviting me to come just for a quick 5-minute overview of the EU and international regulations. So yes, I'll jump straight in because I've only got a limited amount of time. So I had the pleasure to basically talk about why should we be looking at wind propulsion technology. And of course, IWSA has many different technology providers, including Bound for Blue. So first of all, we've got some serious challenges involved in meeting the 2030, 2040 and 2050 goals set by IMO. And of course, if we just take a fuel perspective, then we've got issues around the high price of the fuels, the supply of those, and of course, a massive investment that's required. Wind propulsion, however, is not just a carbon zero emissions, but a zero emissions energy source across the board. So actually you're ticking the boxes on pretty much everything that you need to reduce, including the carbon which is being regulated for. It's available now, it's available globally, and it's pretty abundant, and we're increasingly good at monitoring that and understanding the routes and the weather routing that is required. But also, this is used, it's an energy source that's delivered to the point of use. So there's no mining, refining, transporting, bunkering, or storage of the energy source. It's pretty much delivered to the point of use at zero cost. Now, why should we be looking at this increasingly now? Well, we have two main areas which in regulation are being used. One is on the technical, one is on the economic. Now, the EU has stepped forward with both economic and technical measures in front of IMO, but I'll touch on that in a moment. So from the economic perspective, we have already enforced the EU ETS and shipping's inclusion in there. And I think probably most people on this webinar already understand what this means. But just very quickly, if you have an inter-EU voyage, then 100% of the carbon will be calculated and paid for at the rate, which I think is averaging around $65 per ton of carbon release at the moment. So that's 3.1 tons of carbon per ton of fuel. And if you have a voyage that's coming into Europe or going out of Europe, then only 50% of that fee will be charged. Now, there's a stepping in of this measure. So for this year, it's only 40% of that total is payable. Next year will be 70%. And then finally in 2026, 100% of that will be payable. We also have the fact that it's only carbon currently, although methane and NOx or N2O will be factored in from 2026 as well. So it'll be CO2 equivalency. And finally, there will also be an extension from the 5,000 GT vessels and above. Hopefully, we will be seeing that reduced down to 400 GT. And I say hopefully because that actually brings a lot of the smaller vessels, which can have substantial reductions, into play. And many of those are actually built and installed in Europe itself. So we've got the cost increasing, and this, by 2026, this can certainly be a couple of $100 per ton of fuel for those external voyages from the EU. But on January 1st, 2025, so in a few months' time, we also have the Fuel EU Maritime regulation, so the technical regulation of reducing the greenhouse gas intensity of the energy used on the vessels. Now, this is again stepped in with a 2% reduction required by 2025. 2030 is a 6% reduction and going further on. So wind propulsion installed would actually reduce that carbon or that greenhouse gas intensity. But also because wind is a completely zero emissions source, there's also an additional reward factor, which, at say 10 to 15% of the energy provided would actually make the vessel compliant in 2025, pretty much in 2030 as well, and generating benefits and reduction in cost for the penalties incurred. Now, from an IMO perspective, we have the midterm measures which are being discussed at the moment, which include a global fuel index or standard, and also some form of carbon levy, very similar to the two items that I've just mentioned around the EU. However, we also have the EEXI and EEDI and the CII, the Carbon Intensity Index. So the Energy Efficiency Design Index and the Existing Ships Index, these both are benefited by having sales included in those, and obviously that will help with compliance, and has been mandatory for about a year now. So most ship owners have already factored this in. With CII, it's still quite controversial. There are a lot of exceptions, a lot of variations amongst ships, and I'm sure all the ship owners on this webinar will understand exactly what I'm talking about when I say it is still controversial. But the issue around here is as the stepping in of the stepping up of that carbon intensity over each year means that an A-rated vessel will actually end up potentially as a C-rated vessel by 2025, 26, 27. With wind propulsion on board, therefore, you're actually able to maintain your better ranking or rating here, keeping it above C or C and above. And that also, if we look at 2026, again, the review of CII could well include some teeth. So at the moment, it's just if you're not compliant for 3 years under D or 1 year under E, you have to do a revised SEMP. However, if in 2026 that review actually starts to include penalties, then wind propulsion really comes into its own too. So I've covered pretty much what is in place at the moment, but of course with the GFI and also the carbon levies that may be coming in globally, wind propulsion is certainly a critical tool in the toolbox for decarbonisation and compliance. So thank you.
Great, thank you very much, Gavin. A great insight into how we can help to sustainably decarbonize shipping using wind propulsion as an abundant zero emission energy source available at point of use at zero cost, while helping to keep vessels profitable and compliant amid increasingly strict regulations. Be very interesting to see if the CII review has that kind of bite that you referred to. So, ladies and gentlemen, next up is Fabian Kowatsch. As a shipping decarbonisation specialist at LDC, Fabian leads the exploration, assessment and management of various decarbonisation opportunities for LDC's fleet of chartered vessels. These include energy-saving technologies, devices, from paint upgrades, wake equalising ducts, and alternative fuels to engine load optimization, voyage optimization, as well, of course, as wind-assisted propulsion. So, Fabian, over to you. The floor is yours.
Thank you very much, Roderick. And thank you, Bound for Blue, for hosting this webinar. Let me start by sharing a little bit about what moved us into decarbonization in general. So over the last 5 to 7 years, some major changes in the shipping industry have led to a significant rise in environmental awareness among all stakeholders, but also and especially among vessel charterers. The implementation of the IMO 2020 regulation, limiting the amount of sulfur emitted into the atmosphere, showed that environmental concerns were starting to be tackled more stringently than ever before, and that the industry was capable of change, and that in a relatively short amount of time. So all stakeholders had to, and actually did, adapt. This encouraging development also meant that there would likely be more major changes coming to the industry, pushed by regulators, just as Gavin just explained. So that's when cargo owners like us started to understand that we needed to be proactive in our approach to the environmental impact reduction, and that we could not stand on the sidelines hoping for vessel owners to solve the problem by themselves. So, as explained, the IMO enhanced its GHG reduction goal for 2050 to net zero, and the EU integrated the shipping sector into its already existing emission trading scheme and developed the FuelEU Maritime Regulation. These developments only increased our focus on environmental aspects and more specifically on greenhouse gas emissions. The Shipping Innovation Leader, a position specifically established in Louis Dreyfus Company's freight platform, started building a dedicated decarbonization team, which I'm a member of, to look into all possible technologies to reduce CO2 emissions from our chartered fleet. Another major task of my team is to build partnerships with owners and build projects to be able to deploy these technologies, of course. And it was also around that time that the first installations of wind-assisted propulsion systems started to make the headlines and caught our attention. However, there we were presented with another dilemma, which wind propulsion to choose from. So we started an assessment with the Lloyd's register. Reason being is that when we started looking at WAPS technologies, it was evident that there are many different suppliers, many different solutions out there. Rotors, rigid wings, semi-rigid wings, kites, and of course, Bound for Blue suction sails. And all of them have pros and cons, and none of them have been around for a long time. So to be able to find out which of the technology fits our specific needs best, we turned to Lloyd's Register to support us. LR, with its long history as a class society and their great wealth of experience, had the necessary expertise and competence to help us by building this comparative study. It allowed us to compare the different technologies side by side in the same theoretical conditions and to derive the potential fuel savings. By then translating those into emissions, regulatory, and finally monetary savings, we were able to identify the one that would have the shortest payback period when put against the initial investment. And then we added other factors like robustness of the equipment, required level of crew involvement and training, ease of use, technological maturity, but also weight and size of the sails into our evaluation. So combining all these, we were comforted in our choice to go with Bound for Blue's e-sails. Next question that came to our mind was, where do we install these sails? How do we start this? So we identified a vessel that was ideal for a first installation. And that vessel is the Atlantic Orchard. She's owned by Visby Tankers, and their involvement has been absolutely critical in the choice of the vessel. It's their openness to innovation and their support of the entire project that has allowed us to take on this challenge, knowing that we could count on a reliable partner. On top of that, the Atlantic Orchard also presented additional advantages. She's one of our 2 vessels transporting juice from Brazil to Europe. And these vessels that we are chartering for a very long period are bulk carriers that have been modified to be able to accommodate the refrigerated tanks in which the juice is transported. They are being loaded and discharged via manifolds, which means that they always go to the same jetties and shuttle between those. These few facts are presenting several major advantages for our project. Firstly, the stable trade pattern allows to avoid variable port restrictions. Those can be a concern for the tramping fleet, but in this case, we were able to study the port restrictions like air draft or loading and discharging operations ahead of time and make sure we would comply with all of them. Secondly, shuttling between the same ports means that we can predict the encountered weather and wind conditions, very accurately. That allowed us to calculate the savings and build a reliable business case. Thirdly, the long duration of the chartering period ensures that we have a sufficient amount of time to harvest the benefits of the e-sales up until the break-even point and beyond. And finally, the fact that the vessel is consistently sailing into the EU added an extra financial upside thanks to the EU regulations that Gavin explained before. Now, such a project obviously presents many organizational challenges. There are many parties involved, and there are regulatory difficulties as well as specific technical obstacles to be overcome. During the engineering phase that we are in currently, and I'm sure that there will be more challenges ahead once we get into the manufacturing and installation phases. And that is why I think that a critical component to the project is who you work with and how you work together to overcome such challenges. I already mentioned the vessel owners, Visby Tankers, who helped us numerous times when it comes to finding solutions regarding outfitting of the vessel. And whether it is for the placement of the sails, the integration to the vessel's electrical systems, or interaction with the class society DNV, who we need for the approval of the modification, Visby Tankers has been of great help. Now, I would also like to mention Lloyd's Register's support here, without whom we would not have been able to build this project to begin with. It was their continuous help in understanding and figuring out the EU regulations, and specifically Fuel Euro Maritime, that allowed us to fully grasp the savings that we could generate with this project. Especially at a time when there were still different versions of the regulation and they still contain inaccuracies and unclear passages, LR helped us cut through all of that. I already mentioned how the comparative study then contributed to guiding us to our choice of the most appropriate WASP technology. And we also chose Lloyd's Register to be the naval architect and produce the engineering for the retrofitting. So their role in this project really can't be overstated. Finally, Bound for Blue. Obviously, they are supplying the e-sails for our project and are logically a central partner. But not only that, they also provided an in-depth analysis of the attainable fuel savings and conducted a feasibility study that kick-started the whole project. Since we signed the contract with them, they have been by our side providing counsel, feedback, and lessons learned from other projects that they have already completed. This allowed us to avoid some challenges altogether. I'll finish my part by sharing a little bit what led us to wind propulsion specifically, and why we wanted to incorporate it in our fleet among all other solutions that are out there. So we started this decarbonization journey with an open mind and try not to exclude any technology from consideration. So some are more applicable to our fleet, others less, and some are more mature than others. And we have identified and deployed several efficiency improvement technologies. I could, for example, mention low friction paints, wake equalizing ducts, or engine load optimization with the fuel opt system from Manta Marine. However, WAPS are unique in the sense that they provide free propulsive power, whereas other ESTs reduce your consumption by making the vessel more efficient. And in the same vein as what Gavin explained, we are also studying and evaluating alternative fuels and the applications. We have partnered with TotalEnergies on that project. And one fact is clear, the alternative fuels, whichever they will be expensive. And that is why we think that the free wind energy will play a major role and harnessing it will be key. And this concludes my part. Thank you.
Thank you very much, Fabian, for that analysis. It's really inspiring to hear what you've been up to at LDC as a forward-thinking cargo owner, looking to future-proof your operations alongside vessel owners. And as you mentioned, I think trusted partnerships are so important to achieving concrete savings in a fast-changing world with all the uncertainties. So, ladies and gentlemen, now let's turn to Santiago Suarez, a ship performance manager at LR, who's dedicated the last 12 years of his life to leveraging state-of-the-art evidence and methods to identify sustainable pathways to decarbonize the maritime fleet, helping clients and stakeholders make the best decisions based on the best science available. So in his current role, he and his team are responsible for supporting clients through advisory services focused on energy efficiency, naval architecture, and marine engineering. Santiago, the floor is yours. Over to you.
Thank you very much for the introduction, and thanks for Bound for Blue for organizing and extending the invitation to LR. So when I talk about wind propulsion for commercial ships to some of my friends, they always say that, well, this has been the way that shipping has done this for ages. So what is new? And yes, I agree. In one part, the wind has not gone out of our water bodies, but shipping has moved away from wind due to the commercial and dynamics, technology maturity of different machinery and energy sources. But now shipping is confronting a new paradigm where climate change is driving, or mitigating climate change is driving shipping. And it's not only shipping as well, there's other sectors in transport that they need to adapt. And through this change, wind propulsion is coming out as a potential solution that allows to transition commercial ships. However, different to past sailing days, shipping is technology and supporting infrastructure. The commercial landscape that we have now and the amount of traffic that there is now in our oceans, on top of the competition and the challenges ahead, have evolved, and such the wind technologies need to evolve to that new paradigm and new reality. With these complexities, key stakeholders have approached LR to understand what are the elements or the aspect that needs to be considered in order to integrate wind propulsion, or even starting with the starting point is wind propulsion for my fleet, or which ship is going to be applicable for wind sails. And we have multiple questions that need to be answered, and these are critical to be answered in order for this technology to enter into a more mainstream domain in the shipping industry. And as these questions are being asked, LR tries to get ahead and try to give answers based on science and robust evidence in clear rules and guidance to support our clients. So starting with regulations and standards, there are two basic elements of that needs to be considered for wind technology installation. The first one, it has to do with wind technology integration. This is covered mainly by the class rules, and it requires the assessment of different aspects, such as the structural elements, fatigue, anchoring, and mooring, which is quite really important, especially when you start to have multi installations of devices. So this is quite important. The electrical and control aspects, and as well the machinery. These different dimensions need to comply with the applicable rules with the aim of having a compliant and safe integration of the wind device into the vessel and allow for a safe operation of the vessel when the wind device is installed. As a side note, we recently published our wind notes on wind-assisted propulsion systems in December 2023. When the slides are going to be shared, you can click on the link and you can have a really enjoyable technical read. I think it's important to consider all these aspects because when you are considering the integration of wind propulsion, these aspects need to be considered, as Fabian mentioned, in order to have a smooth integration of the system. The second aspect has to do with ship regulatory compliance. When you install a wind device, it has to align to the regulatory compliance and ship certification of the particular vessel that will have this installation. Here, the vessel, after the installation, will need to demonstrate adherence to the requirements established in SOLAS, for example, MARPOL, cold regs, among others. In a more nuanced way of describing this involves visibility, which is quite critical. Again, when you start to have a lot of devices installed on deck, this is going to be much more challenging, but this has to be, the vessel has to comply with this. The propulsive power, maneuverability, and this, again, this is an aspect that needs to be evolved in the regulations, because there's no clear indication what needs to be, how you comply with the maneuverability of a vessel with wind propulsion. And other aspects is fire protection, and of course, when we talk about energy efficiency, EDI and EXI. So if I were to put the whole aspects of standards and regulations in two main objectives, I can split it in safety and energy efficiency. So how LR sees these aspects? So first, safety. The dimension is normally covered by an assessment of safety implications of the wind installation. This process, where key stakeholders on the installation of the project, and we're talking about the ship owner, the wind technology provider, class, and any engineering firm that is going to be involved with the integration of the system. And this was discussed already by Fabian on this case on the Atlantic Orchard. And we have to add in this particular case that the charter as well has a lot of implication, and being involved on the process has driven a really smooth transition, the learning curve for this particular installation. So the idea is of this engagement is to detect potential risk and find solutions that eliminate that risk, so the vessel can operate safely when this operational. So the objective of this engagement, as I mentioned, is to ensure that the wind installation will have no adverse effect on the safe operation of the ship, either during normal operation or if there's a failure on any of the wind devices. The second part is that we need to ensure that with the wind device will cause no harm to the ship crew, either under normal operation or if there's a failure of the device. And all these changes that we are going to be doing, this has to have as a minimum approval and a survey of the ship modification for the compliance of the classification rules and the flag state regulatory compliance. So now moving on a little bit into energy efficiency, and Gavin covered a lot of the indexes that you really like, the EXI and the EDI. Wind technologies are categorized as by the IMO as innovative energy efficiency technologies, which reduce greenhouse gases emission. These innovative devices are covered by the MEPC Circular 896, and you can look in the web for the circular so you can read it. Again, another recommended technical read that you must have. The important point here, beside the defining wind technologies as innovative devices, is that it allows for the calculation of the effective power of the installation of the wind devices. And it uses global matrix, wind global matrix conditions in order to estimate that effective power. And that calculation of effective power goes into the EDI EXI formula to estimate the benefit. And LR has been supporting as well LDC on the calculation for the new installation, and that's going to be applied as well for the EXI, but as well for the calculation of the fuel EU reward factor that I'm going to talk a little bit forward. So based on the experiences that we have had in the past with wind propulsion retrofits, I think we can have several key recommendations if you're thinking how to move forward. The first one, and Fabian will as well talk about this, is engage really early on with the key stakeholders to have a detailed definition of the scope of design and engineering that will ensure a smooth transition or installation of the wind device. And again, two key aspects of these discussions has to be the wind devices integration and how that ship is going to achieve compliance. And the other one is establish a close communication between the different technical teams. Detecting early on any issue allows to reduce the cost, but as well the time for these projects. They are, even though that they're more complex retrofit projects, still is really important to recognize the challenge of retrofitting a wind device on board the vessel. It's not impossible, but it's something that you need to have in the right framework in order to move forward. The second aspect is that you will have a benefit on energy efficiency or carbon intensity. You can coordinate the retrofit of the device with your SEM Part 3. And that's in the sense that you know what is your score when the drive dock is going to happen, so you can put that measure on your SEM Part 3 as part of that, as part of your way to reduce the carbon intensity. As well, as we mentioned, the wind installation allows you to reduce the EXI with the calculation based on the circular 896. And as well, and really important, beyond the regulatory compliance as well, is that during this time you need to as well be asking, and what is the wind solution is suitable for the vessel routes that I'm operating, and does what vessel designs aspect will impact the decision-making process of the vessel. And there's commercial implications. Let's say a spot chartering is going to be more challenging than time charter because you don't know where it's going. So adding that risk into the business case is important to address early on the decision-making of the wind propulsion system. And to that end, LR helps our clients with a framework. It's a 9-step right now, but the system and the services that we can offer are different and wide varied and are tailor-made to the needs of the client. But in this representation of the services, we start on a global framework where you have a fleet of vessels, and then you say, okay, which vessel is suitable for wind? And on that assessment, we start to analyze what are the commercial constraints, the routes, the type of vessel, the available space, what are the air draft constraints, the speed that you operate normally, and what are the port activities, so we know those foldable sails are for you, or a rail system is better, or just a fixed system because the capex is a little bit lower. So under that framework, we start to reduce and start to find candidates that are suitable to be the first wind propulsed system, ships. And after that, we start to keep on filtering until we find vessels allocated to routes that give the best business case. And then the next question is, what technology is suitable for that? And this is where the work that we did for LDC start to come into play. And how we approach this, as Fabian mentioned, there were 5 different candidates and different providers of wind propulsion devices. We have the baseline case, which was the routes that they normally operate. And after that, we send the base case to the different wind propulsion vendors. They've simulated the performance of their devices, trying to eliminate, and this is really important, to eliminate any weather routing advantage. So we wanted to have a fair play for all the devices. We allow them to recommend what will be the optimum number for the vessel that LDC had. After we receive all the evidence, we on the side we perform our own simulations to contrast the solutions and the answers of the fuel saving gain and what was the business case for that particular vessel. This allowed us to confront when the difference in solutions were too large. We can confront them and say, what was the difference? What is the rationale for this large difference? And try to align the results and see and understand what was done. With this, we allowed LDC to have high confidence on the numbers that were provided to them for them to make the decision of which device was the best. And as we move forward, like we do the EXI calculation, as we mentioned, we can do the conceptual design study, and now we're supporting them on detailed engineering studies. But as well, we are at the moment having different projects where we are doing in-service performance verification through ISO 19030, and it's quite exciting because this is validating what was in theory measured against what in the reality is happening. And we have the Maersk Pelican as an example, and the report for that vessel is publicly available. And it's really a really satisfactory engagement to start from those wind propulsion is good for me to what is the reality of that device doing to my vessel. So finally, talking again about Fuel EU, and we want to present what Fabian saw on our estimations on the Fuel EU and how this is a deal breaker when making the decision. So I'm going to cover a little bit about the Fuel EU, just going really far, superficial because Gavin already covered this. But the Fuel EU is the Fuel EU Maritime is part of the Fit 55 package, aiming to enable the EU to reduce its net greenhouse gas emissions by at least 55% by 2030 compared to 1990 levels, and to achieve climate neutrality in 2050. The regulation lays down uniform rules imposing a limit on the greenhouse gas intensity of the energy used on board by a ship arriving at, staying within, or departing from ports under the jurisdiction of the EEA country. There is an obligation in the future to use onshore power supply or zero emission technologies in port under the jurisdiction of a member state. It applies to ships of 5,000 gross tonnage operating to, from, or within the EU, and there will be penalty associated with the use of fuels with high or greenhouse gas intensity over the target year, and this is changing every 5 years. The Fuel EU regulations were passed into law in the 25th of July 2023 and starts on the 1st of January 2025. So not that long, another 6 months to go to start having to measure the impact of these new regulations. Users of wind propulsion technologies gain double advantage. One is the fuel savings that you achieve due to operating the vessel through the routes. The second one is the Fuel EU Maritime Reward Factor, as Gavin mentioned. If you manage to achieve to demonstrate that the installation device achieve higher than 50% gains, and this is using the methodology established on the Circular 896, then you have 5% discount. And for the case that I'm presenting here, that's the assumption that we have, that it's 5%, the installation achieved more than 15%, so you have a 5% discount. On the left-hand side, you have a vessel operating with VLC, very low sulfur fuel oil, and on the right you have the same vessel operating with the same fuel, but you have the wind system installation. Because of the wind installation, you see an important drop on the greenhouse gas intensity established for the ship compared to the business as usual case. In the bottom, you see how the penalties for Fuel EU start to happen in each 5-year period, and you can see how it's increasing every 5 years until 2055 or 2050 to 2025. When you have your wind ship vessel and you have this 5% discount, you start to see that in the first period, 2025 to 2030, there's no penalty associated for this vessel. And as well, you can see that there's a lower penalty as the greenhouse intensity required is more stringent. So what does it mean on numbers and total cost? So you can see that the first part is that you save 52 euros per ton of CO2 emitted, CO2 equivalent emitted. But as well, because you are way below of that threshold, you have surplus. And if you add on this, you are gaining 200% of that penalty that you didn't have before. So the surplus, of course, how you apply it, it will be the benefit that you have. But it allows you on the first 5 years, and this is what LDC saw, that you're going to have surpluses that you can use as you need to on your fleet. But if we start to move to 2030, when the stringency level there is at a stringent level, you don't have any more surplus value, but you have a reduced penalty this is the benefit. So your benefits are going to be still high, and it will be reducing as we move forward to 2050 because the stringency of the greenhouse gas intensity. However, and an important point, if you start to introduce biofuel or methanol, the business case for the wind propulsion plus the fuel EU regulation creates a lot of incentives in order to start moving into wind propulsion and alternative fuel as well as a powerful combination. As the energy transition, there's no silver bullet for anything, and we recommend when you are thinking about wind propulsion to reach out to the experts to allow you to establish this simulation case in order to see what is the scope, which ship is your best candidate to start piloting the test, or if you are convinced of the wind propulsion, to detect which are the most critical for your business case and your business to get ahead of the regulations and support you on your growth. And finally, LR will be publishing its wind assist propulsion retrofit guide, similar to the engine retrofit. And the idea is to promote what are the challenges, the technologies out there, how to navigate these waters with wind, and hopefully this will be out soon. Thank you very much.
Thank you very much, Santiago. Great stuff there. I think particularly highlighting the importance of defining the engineering scope really early. Excellent, ensuring excellent communication between the technical teams, getting all that in place to ensure smooth installation, commissioning and compliance is really important. And I think your 9-step wind-assisted kind of journey to help owners assess potential retrofit projects also super useful. And and not least the potential reward factor or greenhouse gas intensity discount under the Fuel EU reg seems to me to really strengthen the business case for wind from a cost perspective. So thank you. So our last speaker is none other than David Ferrer. He's the CTO and co-founder of Bound for Blue, and really our host today. Before setting up Bound for Blue, David worked for European company Zero to Infinity, leading the development of technologies designed to provide access to space with stratospheric balloons, human space travel, and a dedicated nano-satellite LEO launcher. David's invented more than 5 patents in the field of wind-assisted propulsion, for which he's won several accolades, including in 2018, the Innovator Under 35 and Visionary of the Year prize from none other than MIT in the US. So that's quite a big thing. So he'll walk you through the configuration installation of Bound for Blue e-sails, suction sails, and their benefits. So over to you, David. Take it away.
Thank you, Rudy, for the introduction. So as you said, my idea for today is a little bit to share what are the steps that we follow during a retrofit of wind propulsion on a vessel, using LDC project as an example. But before that, I would like to start with a quick introduction on what our e-sail is, or how these suction sails are. Don't worry, I'm not going to do the technical presentation. It's just a quick characteristic. The e-sails should be understood like a wind sail that is able to produce high lift. So let me explain that a little bit. When I mean wind sail, it means that it's a system that is basically following the wind, adjusting the position with the changes in wind direction. So very slow moving, no big moving parts. The mechanics are pretty simple. Low power consumption in those movements, but this high lift part, what means is that they are able to produce a lot of savings with a reduced size. And this is a very important characteristic, because on a vessel, when you want to include the requirements from the operation, from the rule, from safety, you end up having very limited space. So being able to have a high lift device, or being able to have a system that can produce high savings with a small size, allows you to maximize the amount of wind installed power on a vessel. So you maximize the contribution both on savings, on fuel savings, but also on the regulatory compliance of this CII, EU, ETS, Fuel EU, etc. So it's kind of a very important characteristic to keep in mind. And the thing about these sails is that they can be installed on almost any vessels. And in fact, it's rather than the vessel, the important thing to consider wind propulsion, are other factors like the operational profile of the vessel, what are the routes that she's doing, how often does she call a European port, how many days she spends at sea. Those are the key factors to consider on a wind propulsion installation. So basically, as wind propulsion installations should be understood as a case-by-case analysis, we follow a 5 steps procedure that we've been following also with LDC and with all our retrofit projects. The first one, it's basically doing a preliminary case analysis. And this is a free of charge analysis that we do, in which we evaluate for a specific vessel given some routes and for an example configuration. Configuration means how many sails and of which size. We evaluate what are the potential savings that you can get. The goal from this analysis is basically to know and to understand if wind propulsion could make sense on that vessel. If the answer is yes, then we usually recommend as a second step a detailed technical and economic feasibility analysis. This has basically 3 main topics. The first one is selecting the optimum ESA configuration for the vessel. So what is the best configuration, the best number and size of sails that you can fit on that vessel to maximize basically savings and to get a better payback, meeting the operational requirements, things like air draft or things like hatch opening, cargo handling, etc. And of course, all the other requirements from rules and from safety. Then the second step is a conceptual design. The goal is to validate the technical feasibility. So can sails be installed on that vessel? And also identifying all the tasks that are required in this transformation, because if you know the tasks, you're able to know the cost of installation, of transformation and installation. And the third thing is doing a more detailed savings analysis to be able to do an economic viability of that project. Because we know the cost, we know the savings, and you can get a better idea of the IRR, of the payback, etc. So the goal in the end is to validate if wind propulsion installation is feasible and viable on that vessel and for that specific project. So in the case of LDC, as Fabian said before, we did this analysis, and the starting point, there were 3 main, let's say, operational limitations or requirements from the owner. One was air draft, basically limited by the access to the port of Ghent. They wanted to be able to keep using the crane because they're using it for the manifold, for the containers, etc. And the hatches should still be able to open because of some operations that they're doing in the tanks. So doing this analysis, we ended up with a configuration of 4 sails, model 226, which, as you see, basically they are right at the vessel air draft. That was important. That's why it's important to have high lift, because you can have smaller sails. The crane operation can still be done because the 4th sail is at port side, and the hatches can still be open enough to do the operations they have to do. The interesting thing about this configuration is that with those 4 sails, they are achieving more than this 15% of wind installed power, which, as you may have seen in some previous slides, it's very important for fuel U because it's the maximum contribution that you can get. So the interesting thing here is that when accounting for fuel U and EU ETS contribution, the payback was roughly divided by 2. And this is for a vessel that is only trading 50% of the time in Europe. So you can imagine how important taking that fuel U and ETS into account is on an economic analysis. So once the configuration was set and the project was decided that it was viable and we move forward, the next step is in fact designing that transformation and getting the approval from class. So in that process, Bound for Blue acts like a technology supplier. So of course we're delivering the technology, but we also are constantly giving support to LDC and to all the other stakeholders, WSB tankers, LR, etc., on everything that is related to wind propulsion. So we try to bring our knowledge, like aerodynamic interference, how to solve some issues that we may encounter on the integration of the sails, based on our past experience. The goal is to try to have the most efficient installation and integration of the technology. And of course, in parallel, we are producing the sails. And a very important thing that we also do is that we do a specific dedicated optimization of the control system of our sails. We do full-scale CFD analysis of the sails with the vessel in order to better understand the efficiency and define and optimize control logic for every sail for that specific vessel in order to maximize the potential savings. After that, it's hardware work. So the first thing is getting the vessel ready. So installing everything and modifying the vessel as designed to be ready to accommodate the sails. This is basically the main task is steel work for the foundation and cabling work for providing power. And the other thing is installing the sails. So lifting up the sails and installing them on the foundations. In the case of LDC, this is obviously not done yet, but it will be done during the visit of the vessel to shipyard for the 5-year class renewal survey. And as I don't have a video from them, what I have is a video from our past installation that will show you a little bit how the process is. So you will see how the foundations were welded and how the sails will be were installed. So I'm going to share that video with you. So, and just to finish, so we hope that after all these steps, we will be able to replace that image that you see on the right, so that render by a real nice picture of Atlantic Orchard with 4 e-sails, and start producing savings for LDC starting in 2025. Thank you very much.
Thank you very much, David, for those insights. It seems to me that high potential savings, compact size, and pretty attractive return on investment seem to be the secret sauce of your e-sales. And it's nice to see that Airbus is also hooked into this trend. So, ladies and gentlemen, that's given a fascinating look at wind-assisted propulsion, from 3 key perspectives: the charterer / cargo owner, class, and the tech vendor. The key takeaways for me are that wind-assisted propulsion is an economically viable and mature technology to reduce the cost of emissions vis-a-vis the EU ETS and Fuel EU regs, reduce the use of expensive new fuels, and also improve your vessel's CII ratings. Obviously, all installations have to comply with class rules, but the wind's free, so let's get using it. And certainly Bound for Blue and David are there to help collaborate with you every step of the way if e-sales make sense for your specific vessel trading profile, as David very clearly explained. So armed with that information, let's jump straight into the Q&A session. I see we've got some questions already in the field there, and I'll just jump straight in. Question from Will Stevens. Sorry, I should have gone from the bottom, but we'll take Will's question first. What subsidies, if any, are available from the EU? David, why don't we start with you on that one?
So there are some programs, some subsidies from the EU. I think the main known one is the Innovation Fund. but they really depend on the stage of the process that you are. So if there are interest, they can get in touch with us. And of course, we can analyze what is the best option. That's from what I know, but I don't know if the other participants know maybe more than me.
Gavin, maybe?
Yes, I think the innovation fund will be the one that is increasingly available for shipping related activities, but obviously that's the EU ETS funds will be coming into that, but it's organised by flag states, so you have to really go through the flag state opportunities that are arising in each country. Other subsidies obviously are around things like the Horizon Interreg projects, if those are more on an R&D level as well.
Great. Thank you very much. And just moving on to the first question that was sent in from Ioannidis. Does the vessel deck have to be modified to accommodate the loads from the wings, and to what extent? David, I think that's a technical question for you again.
Yeah, so yes, the deck, so you have to install some foundation, so you need to reinforce locally the deck where you will be installing the sails, because of course the sails are providing design loads, wind and inertia. This is basically what LR in LDC project are doing. So we define the design loads, the engineering company designed that foundation, and you have to install them. Conceptually, it's like installing a deck crane. So you have to locally modify and reinforce the structure.
Okay, great. We don't have time for too many questions, but I'll just jump into a question from Jay Miles. Question for Santiago. For the fuel E regulation, can wind-assisted propulsion reward factors be interpolated based on actual P-wind, P-prop percentage, or are they fixed for 0.99, 0.97 and 0.95? I'm not too sure if I totally get that, but you can have a go.
Oh yeah. No, I think it's prescriptive. So if you are above 15 or above, you receive 5. If it's below 15, let's say 14.5 to the next boundary, you receive the 3%, and then it's by blocks. So you don't interpolate.
Okay, great. And a question from Alfred Rappaport. What actual fuel savings are you estimating, David?
In general, or in so in general, I have no answer. That's why we do the preliminary case analysis, because that's going to depend on the vessel, the trades, etc. On the LDC project, I guess Fabian has better the figures. Do you have them in mind, Fabian?
Unfortunately, I cannot share the precise numbers here to the public because they are proprietary information. But I can share that we will have a fuel savings of over 10%.
It seems to me that fuel savings, are probably best calculated on a case by case basis rather than kind of generic promises that aren't really that satisfactory.
It will really depend on the sales you choose, on how many, etc. So, and the trade and the wind conditions. So it's not like a fixed number or percentage number that can apply to all types of vessels.
Yeah, because of there's so many variables and different parameters. Yeah. Let's move on to a question from Savio at Emirate Maritime. Have there been any issues reported with deployment or otherwise? And is the vessel staff involved in maintaining the sails? I guess that's another question for you, David.
So concerning maintenance, so yes, there is some basic maintenance. So the clear example is the sail is orientating to the wind, so we have a slew bearing with an electric motor. So this slew bearing should be greased, as again like a deck crane. So yes, the crew will have to do this basic maintenance. And the first part of the question was, sorry, can you repeat?
Have there been any issues reported with deployment?
With deployment from, I assume, on the other installations, I would say.
Yeah, on you know, I mean, on projects that have gone through.
So as any engineering project, there are always challenges, as Fabian was saying, but nothing that has been a showstopper or a big concern. So all projects have been, we have installed the sails, they're already operating on those vessels, savings are coming. So I would say that there's not been a major no-go.
Great, thank you, David. I'm afraid, ladies and gentlemen, we have actually run out of time. Thanks for your attention. It's been great listening to all the panelists, and thank you for their time. Just to close the session, back to you, David, since you're our host. Would you care to give us just some closing remarks, just to send people on their way and to wrap things up?
Yeah, sure. So basically, I would like to thank you, all the attendants, for the interest, and those who could not attend, they will probably see that afterwards online, because the presentation will be shared. So thank you to them also. Thank you to the panelists and to everyone here. And basically, my main closing, it's pretty aligned with what you said. Wind propulsion, I think, is already here. It's feasible. It's possible. Technology is working, so basically we have to move forward, and it may not be for every vessel, and that may not be the best commercial pitch, but that's why we do this 5 steps segment. But they can also get in touch with LR. They are basically doing the same feasibility analysis that will show where to install wind propulsion and where to install all the technologies. But I think there is no doubt that wind propulsion will be here and will remain for very long.
Yeah, David, there's just one very last question that's come in, which I think is quite important for you to address, and that's like, how can we enhance? This is from Ilko Liemans. How can we enhance the narrative for wind propulsion and convince the big conservative powers in the maritime industry that this is a go?
So basically, our strategy, the things that we're following, is basically installing our technology on different vessels, and we are validating performances with third parties. So, for example, on one of our installations with Amasus, a Dutch ship owner, we are doing this third-party validation with LR. So Santiago is working on that, because we want them to be publishing the results. So I think that the key thing is going to be basically showing that the technology works, publishing results, and enhancing transparency.
Yeah, great. So the proof is in the pudding, in other words. So, ladies and gentlemen, thank you for attending. As David said, Bound for Blue is there to help. Thank you for your time, and have a good rest of the day. Thank you to the panelists. Cheerio.
Thank you, Roderick. Thank you, everyone.
Thanks.